Hi there, folks. Today we're looking at solving using square roots. And really solving using square roots is kind of going back to the idea of using inverse operations and working backwards to order of operations in a more literal sense. Okay, so solving using square roots, remember that undoing squaring something really just takes using the square root. Exponents and roots are inverse operations, all right? And when you think about that from the bigger perspective of solving equations, that makes sense when you think about IRMDAS. Remember, the E and the R kind of go together. So to undo to undo squaring things, I can use square roots. For example, if I look at something like this guy, here I've got x squared equals a 9. So to undo squaring something, I'm going to take the square root. So I take the square root. Whatever I do to one side, I have to do to the other side. Okay? And so what happens here, and most students will look at this and go, oh, the square root of x squared is x, all right? And they're kind of right. And the square root of 9 is a 3, and that is right. But the problem here is, remember, there's a weird technicality. The square root of x squared is actually the absolute value of x, okay? So technically, the square root of x squared is the absolute value of x. And then we're absolutely right, the square root of 9 is a 3. But now absolute value, you got to split up. So x equals a 3 or x equals a negative 3. So we actually get two answers here. And we can kind of write that succinctly and say x equals plus or minus the 3. Okay? You can write it separately. That would be fine also. But it's this idea that there are two values squared that give me a positive 9. All right? Positive 3 squared is a positive 9, but negative 3 squared is also a positive 9. All right? And it's because of that idea of, well, technically the absolute value of x, the square root of x squared is the absolute value of x. All right? Same thing here if I were to take the square root of each side. Technically, the square root of x squared is the absolute value of x. And then the square root of 49 is a 7. But then, of course, absolute value, x equals a 7 or x equals a negative 7. So x equals plus or minus 7. Okay? And again, you can write it as just plus or minus 7, or you could write it as two separate values. All right? This one, same thing. To undo squaring something, I take the square root of each side. But then technically, the square root of x squared is the absolute value of x. And now over here, you can break this down into 4 times 6. I'm going to leave it in radical form. The square root of 4 is a 2. But again, I'm also going to split this up. I'm going to say, hey, this equals a positive 2 root 6, or it equals a negative 2 root 6. That's how we solve the absolute value. All right? And once again, I could write that as plus or minus 2 root 6. Okay? And so here's the thing. It seems like a lot of work to sit here and do the absolute value every time and then, split up the absolute value and solve the absolute value. We could do that literally every time, but then we're going to do twice as much work as we need to do. All we need to remember is, hey, when I take the square root of each side, it's plus or minus that value, all right? And so the idea here is we want to use a shortcut, and hopefully that makes sense to us, that when we say, okay, something squared equals 49, well, yeah, 7 squared equals 49, but negative 7 squared also equals 49, all right? And so it's that idea of that whenever I take the square root of each side, I have to have plus or minus that value, and it's for a couple different reasons. One, it makes sense when you think about squaring something, but two, it's because of the technical aspect of this being the absolute value thrown in there, okay? So instead of doing the absolute value, because that would be obnoxious to do that every time, we're just going to remember that, hey, whenever we take the square root of each side, we're going to do plus or minus, okay? So if I look at this guy, and so now we have more than one step. So again, back to the foundation of solving equations, we have to work backwards through order of operations. So I undo addition and subtraction first. So I'm going to subtract the 1 from each side. Now I'm going to undo multiplication and division. So I'm going to divide each side by 2. Now I'm going to undo the exponent by doing the square root of each side. And again, I'm going to simplify this thing. The 8 is 4 times 2, so it's going to be 2 root 2. But because I took the square root of each side, it's actually going to be plus or minus 2 root 2. And that's it. If I look at the next one, notice I have parentheses here. If I'm working backwards sort of operations, I have to undo what's outside the parentheses first. So I'm not going to add 2 to each side because it's trapped in parentheses. To undo squaring something, I'm going to take the square root of each side, which gives me an x minus 2 equals, because I took the square root of each side, I have to do plus or minus that value. And now I can undo what was in the square root. Now I can undo what was in the parentheses here by adding 2 to each side. Okay? And so here's the thing. Right now it says, positive 6 plus 2, but it also says negative 6 plus 2. It really is 2 things. And if I wrote it as this, 2 plus or minus 6, okay? Well, think about that, what that means. 2 plus 6 is a 4. 2 minus 6, 2 plus 6 is an 8. Math is hard. And 2 minus 6 is a negative 4. So I actually get 2 answers, a negative 4 and a positive 8. Okay? But that's what the plus or minus means. It means I have 2 things, I have 2 numbers, I have 2 operations, I have 2 answers. Okay? If I look at this one, once again, I have parentheses. I'm going to undo that last. So I'm going to undo the exponent by taking the square root of each side. So that leaves me that x plus 6 equals, this is once again going to be plus or minus the 4. Now I can undo what was in the parentheses by subtracting the 6 from each side. And once again, I have 2 things here. I've got a negative 6 and I have a plus or minus 4. It's saying, hey, I've got negative 6 plus 4. I've got negative 6 minus 4. So negative 6 minus 4 is a negative 10. Negative 6 plus 4 is a negative 2. So those are my 2 answers. Okay? Anytime I have a plus or minus, it means I have 2 answers. And if I can figure out what those 2 answers are by continuing to simplify, then I should continue to simplify, okay? In this one, once again, I'm going to undo the exponent, so I'm going to take the square root of each side. That leaves me with an x minus 3. Over here, I'm going to simplify this. Remember, 50 is 25 times 2. The square root of 25 is a 5. The 2 is still trapped. Because I took the square root of each side, it's going to be plus or minus that value. Now I can undo what was in those parentheses by adding the 3 to each side. And from here, if I kind of do the same thing that I've been doing, that's 3 plus or minus 5 root 2. Okay? And then from here, I've been simplifying that further, but really these are not like radical terms, so I can't combine these. I can't go any further. This is my answer. I'm just going to leave it like this. Okay? And of course, if I wanted to, I could plug this into a calculator. I could get 2 values that would be decimal approximations. And that would be really good if I was maybe graphing those points or something like that. Or if this was a word problem where it was giving me some real world values, I wouldn't want to leave it like this. I would want to plug it into my calculator. Okay? For our purposes right now, we're just going to leave it in terms of the square root. If we need that decimal approximation, we'll grab our calculator and plug it in. Okay? If I look at this one, once again, I start outside the parentheses. Outside the parentheses, I have times a 1/2, and I have an exponent. Well, I have to get rid of that 1/2 first, so I'm going to multiply each side by 2. Now I'm going to undo the exponent by taking the square root of each side. And again, I'm just working backwards through order of operations. I undo multiplication, division, then I undo exponents, roots. Then last, I will undo what's in the parentheses. Okay? Don't forget the plus or minus here. This simplifies to a 2 root 2. And now to undo what was in the parentheses, I'm going to add that 2 to each side. And once again, these are not like radical terms, so I'm just going to leave it in this radical form. 2 plus or minus 2 root 2, and I'm done. Okay? Once again, I could plug that into a calculator if I need the decimal approximations. All right? If I look at the next one, once again, working backwards through order of operations, I undo addition and subtraction first. So I undo the subtraction by adding the 4 to each side. Now I undo the multiplication by dividing each side. Now I undo exponents by taking the square root of each side. Oh, guess I don't need those parentheses now. And now lastly, I'm going to undo what was in the parentheses by subtracting 1 from each side. And again, I'm going to leave this in this radical form, -1 plus or minus the square root of 11. okay? If I look at the next one, again, I'm working backwards sort of operation. So I undo the addition by subtracting. I undo that 1/4, that multiplication, by actually multiplying, because remember, 1/4 is really just divided by 4. Now I'm going to undo squaring something by taking the square root. And over here, don't forget your plus or minus. And then remember, we can take the square root of negatives now that we're in Algebra 2 and we're all grown up and we understand imaginary numbers. So remember, this is going to be 2i root 2. Okay, remember the I comes out for the negative, so it's an imaginary number, but then 8 is 4 times 2. The square root of 4 is a 2. The other 2 is still trapped. Okay? And now I'm going to subtract that 1 from each side. So I get a -1 plus or minus 2i root 2. All right, so instead of, see, in the past, we would have just said no solution for this one, but really it's more accurate to have said no real solution for that one, because what we have here is we have complex solutions, okay, which basically are imaginary things that have imaginary numbers involved in them, okay? If I look at the next one, same kind of thing, working backwards sort of operations, I'm going to subtract the 15 from each side. Then I'm going to divide each side by a -2. Now I'm going to undo this guy by taking the square root of each side. And again, don't forget the plus or minus. Okay? Especially when we end up with something that works out really well, we tend to forget the plus or minus. When we still have the square root, we oftentimes remember it, but then all of a sudden we get one where it works out nicely and we forget. So make sure you have that plus or minus. And then if I look at something like this guy, you might think, hey, let's solve this thing by factoring. And you could try factoring. It won't necessarily work, okay? You could subtract that 5 over to the other side, and you could build a bridge, two numbers that multiply to a 20 but add to a 10, that kind of thing, all right? But we want to kind of work our way through this using the square root to solve. And so if I want to use the square root to solve, hopefully you recognize the trinomial that we're looking at. When you see x squared plus 10x plus 25, that's a special kind of trinomial. That is a perfect square trinomial. See, if instead of subtracting the 5, if I were to go ahead and build a bridge right here and say, hey, two numbers that multiply to a 25 but add to a 10, well, that would be a 5 and a 5, which means this thing factors into an x plus 5 times x plus 5, which of course we rewrite as x plus 5 squared. And so what happens here is I find myself in the situation that we've been dealing with throughout this lesson. I have something squared equals another value. Well, if I have something squared, I can solve by using the square root. So I take the square root of each side. Once again, don't forget the plus or minus. And now I subtract this 5. And hopefully when you see the answer, x equals a -5 plus or minus root 5, when you see that answer, it should make you realize, well, that's why I would never be able to solve this by factoring. The two answers are irrational numbers, okay? Factoring will only work if you get answers that are nice, neat values, that are rational values, okay? And so if you had subtracted the 5, you can't solve it that way. It's impossible. But by factoring what I already have over there, by factoring that x squared plus 10x plus 25, by factoring that perfect square trinomial, I end up in a situation where I can solve using the square root, okay? So I just solved something that I would not have been able to solve otherwise, okay? Same thing with this one. If I were to add that 1 over and try building a bridge, it's not going to work, okay? I can't solve that one by factoring, but because it's in this special format where this thing is a perfect square trinomial, two numbers that multiply to a 9 but add to a -6, I can factor this thing and end up with a situation where I can solve using the square root. See, this guy gives me an x minus 3 squared. And now I can solve by taking the square root of each side. Okay? Because I have something squared equals another value, I can solve using the square root. Over here, don't forget the plus or minus. The square root of -1 is an I. And now I'm going to add that 3 over to the other side. And once again, of course we wouldn't be able to solve this one by factoring because the answer has imaginary numbers in it, okay? Factoring only works when the answers work out nicely, when they're rational answers. And so this is kind of helping us expand our thinking in terms of how we can solve quadratics, okay? It's not just factoring. Factoring only works some of the time. We need something else that can kind of get all of these answers, these irrational answers and these imaginary answers. And so this is where we're heading with this, using square roots in different ways in order to solve quadratics. And really, the big thing that you look at when you see these last two examples is how in the world did we get to this format, all right? How did we end up with a perfect square trinomial equals some number? Because really, this one would have started off like this. And if I'd given you this example, it's the same example. How would I get from x squared plus 10x plus 20 to the example that we just solved, the x squared plus 10x plus 25 equals 5? Okay, that's where we're heading with this thing. We're going to create this situation in the next lesson so that we can solve using the square root. Okay?